morning, students. I am NV Krishna Rao, Assistant Professor in CSE Department. I am handling the compiler design for the 5th semester. So, we'll discuss the SLR passing methods in bottom of passing methods in the last lab. So, we continue with discussing the CLR passing methods. So, today our class to discuss about the CLR, Canonical LR passing method. So we'll discuss the construction of the canonical LR passing tables. So in SLR method, in state I makes a reduction by A gives alpha when the current token is A, right? So here A gives alpha dot, A is in I and A is follow of A. In that particular A column, we write this A gives alpha reduction of this production in I zone. Here, some situations they might be a multiple possibilities, right? So here beta A cannot be followed by the terminal A in a right sentential form. Then beta alpha and state I are on the top of the stack. This means that making a reduction in this case is not correct. So following that previous one, there may be possibility of multiple. So it may differ the derivation. So here, if we consider this example, so we can do in any other way. So we consider additional information in the state. So to avoid multiple possibilities, and we consider the additional information in the state for the reduction of the production, right? So here this A alpha dot beta comma A, so where A is the look ahead of the LR1 item. So A is a terminal or end marker. So here we adding the additional information to avoid some of invalid reductions. The states need to carry more informations, right? The states need to carry more information. So here we will add additional information for the state. So extra information is put into a state by including a terminal symbol as a second component in an item. So to get perfect reduction of the productions, we are adding additional information to the state so that in that particular look ahead symbol we can perform the reduction of the production. They might be, we can reduction might be some are correct, some might be need not required to avoid such type of collisions. There is some problem with SLR passing method, right? That collisions also we can avoid in this canonical LR. Okay, when beta is not empty, the lookahead doesn't have any effect. So if we consider this production, right? In this production, beta is not empty, then that A information doesn't have effect. But here the beta is empty. In this production, beta is empty. Then we will perform a reduction of A gives alpha only if the next input symbol is A. Only when the next input symbol is A. So canonical LR passing method uses LR1 items. SLR passing method uses LR0 items. So LR1 and LR0, the difference is we add additional information to the production. So here we add a terminal. We add a terminal with some information so that the production can be reduced only the when the next input symbol is A. So here dot at the end of the production in a state dot should be the end of the production and A is the next input symbol, then we say the direction will be carried. So here a state will contain the productions. A gives alpha dot. If they are A1 to AN belongs to follow of A, then we can do the direction if the depending on the input symbol either A1 or A2 or AN. Right? The construction of the LR0 items will be the same as the LR0. Construction of the LR1 items is similar. The construction of the LR0 items. But there is a little bit difference in the closer and go to operations. Right? They will be a little different in the closer and go to operations. Right? The construction of LR1 items is similar to LR0 only, but additional information added in LR1. How that additional information is added is the difference in the construction of the closer and go to operations. So that is adding that additional information is the difference. Right? Now, if LR1 is item in I in the closure, now we'll see the closure of I to construct the closure of I. Right? So here I is a set of LR1 items. Every LR1 item is in I will be in the closure of I. Every LR1 item in I will be in the closure of I. Here, if this is the production, dot B dot followed by variable B dot followed by variable B. If dot is followed by variable B, then we add the B productions. Simply we add the B productions. Right? In closure of I and B gives gamma is a production rule of G, then we add this production. B gives dot gamma followed by B. The question now rises how to find this B. Right? Here A gives alpha dot variable B beta gamma A is the in closure of I. So dot followed by a variable. So we add variable production into this closure of I. Right? So we added the production B gives gamma. Okay, B gives dot gamma. It is followed by B. It is followed by B. Then how will you find what is the B? Right? So here B is in the first of beta gamma A. Right? Here the B terminal is found by considering the first of beta A. The first of this beta A. The first of this beta A. Right? If A gives alpha dot B beta gamma A in closure of I, then we dot followed by a variable B. So we add the B production. Then B dot gamma is added. It must be followed by a terminal additional information. How to find that additional information? It is first of beta A. It is first of beta. It is the main point, the first of beta A. So B is first of beta A. Then if I is a set of LRG items, X is a gamma symbol, a terminal or non-terminal, then go to I comma X is defined as follows. Right? Right? X is a terminal or variable. The go to I comma X is defined as A gives alpha dot X beta comma A. X is the input symbol. Then this dot X, the dot X will be coming as X dot, will be in the go to of I comma X. Listen here. Dot X is the item in I. Then X is the input terminal symbol. Then the go to operation on this X input symbol, X symbol, terminal or non-terminal. Then it will be the A gives alpha X dot beta comma A, will be in the go to I comma X, will be in go to I comma X. Okay, dot X will become as X dot. Right? Is it clear? Dot X will become X dot. So that is a go to operation. Now this is an algorithm. So we can see this algorithm in practice by practicing some number of problems. But we'll discuss. So C is in closure of S dash use dot S dollar sign. Repeat the following until no more set of LR1 item can be added to C. So if go to I comma X is not empty and not in C, simply add go to I comma X to C. Right? So simply we add that go to I comma X into C. So go to function is a DFA on the sets in C. Now we'll discuss this algorithm in solving the problems. Right? So if we have the multiple productions, here the production is the same, but terminal symbols are the different. The terminal symbols are different, A1 to A. Simply in that case, we can write the production at one time and it is followed by all the terminal symbols A1 to A. So this is a short notation for the sets LR1 item. Okay. Now this is the given problem. Right? The first thing, what is the grammar given? This is the grammar that is given. S gives A, AB, S gives BB, BA, A gives epsilon, B gives epsilon. This is the given grammar. Whenever a gamma is given, when we are going to solve the as a SLR, canonical LR, LA so we add a new production S dash gives S. So we have to add a new production S dash gives S. Right? S dash gives S. Here S dash gives dot S. The first production is this one. So in the I0 group, we have to consider the S dash gives dot S. And remember that always here it will be the dollar sign. The first symbol will be the dollar sign. Simply, it is a follow of the root. Simply, it is a follow of the root. In most every situation, dollar sign is must. But sometimes the follow of the root may have additional terminal symbols that also has to consider. So in our case, so simply follow of the root is simply dollar. So we are considering here dot s comma dollar. Now dot followed by s. Now dot is followed by s. Then we must include s protections. So what are the s protections? These two are the s protections. Since dot followed by a variable s, we must include the s protections. So we must include the s protections. So here excuse dot followed by AAB dollar sign, BBBA dollar sign. Here to determine this dollar sign, what thing we have to consider? First off, beta A. What is we have seen? We have to find first of beta A. If dot B beta followed by A. In this case, we are writing the dot B protections. We have to consider first of beta A. Here, what is the first of? Simply, there is no beta. Beta is a epsilon. So simply, there is A, that is a dollar sign. Simply, we say it is a dollar sign. That is the reason the symbol here, it is a dollar sign. Why it is a dollar sign? First of beta A. The first of beta A is the dollar sign. So we include a dollar sign. Then S has another protection. So simply add the another protection also. Then it will be also dollar sign. Now, if we observe dot followed by capital A, so add A protection. Add A protection. Right. Then what is the symbol here? First of AAB dollar. So what is the first symbol? That is a terminal lane. So that is the reason we included here A. Next, for this second protection, dot followed by B, capital B, variable B. So we have to include the variable B protection, right? We have to include the variable B protection. Since we have to find first of beta. What is the beta here? B, B, A. Then what is the A? That is dollar sign. In this first of this one, B is a terminal. So the B is included here. Right? So in the A protection, we have added A, terminal A as additional information because first of beta A is giving A. For B protection, we added that additional information as terminal B. Since first of beta A is giving the terminal B. So we include that one. Right? Is it clear? So now there are no more new protections to be added. So the closure of I naught is completed. The closure of I naught is completed. Right? The closure of I naught is completed. Now this closure I naught will have a go to operations on the symbols capital S, capital A, capital B. Because the dot followed by these symbols, then this I naught will have a go to operations on capital S, capital A, capital B. Then capital S is the input. Then dot S will become S dot. Dot S will become S dot. Dot S will become S dot. Right? Is it clear? On go to operation of S, the dot S will become S dot. So when dot is moving from left to right, we won't change the terminal dollar. It will be as it is. Then another production variable is capital A. In this case, it will become dot A as A dot, dot followed by terminal. So we no need to add any other productions. So the closure of I2 is completed. This is I1 completed. Then B is a non-terminal on go to operation. Dot B will become B dot. The dot is followed by a terminal symbol. The no need to add any other productions. So this I3 also completed. Right? Now here I1 group dot at the end. I1 group dot at the end. Is it clear? I1 group dot at the end. So there will not be any go to operations. Then I2. If we consider I2 dot followed by A, so there will be a go to operation on symbol terminal A. Dot followed by a terminal A, so there is a go to operation on terminal A. So we are saying it is going to I4. So this is a I4. We'll see discussed later. Okay. Then I3. I3 dot is followed by terminal B. Dot is followed by terminal B. So here simply on small b, it going to I5. Now what is I4? Dot A is becoming A dot. Dot A is becoming A dot. Then dot is followed by capital A, add A production. Add A production. Right? Add A production. Then what is first of beta A? Here, what is the beta here? The beta is a B. What is A? Dollar sign. So which is giving small b? Is the small b. So small b is the terminal symbol. Small b is the terminal symbol. Right? Small b is the terminal symbol. Is it clear? First of beta A. What is a beta? The symbol after A. That is a B terminal. So we included B terminal. Then what is A? The A is a dollar sign. So first of beta A means first of terminal B followed by dollar sign. So it simply gives B. So it simply gives B. Right? Is it clear? Then dot followed by A. So there will be a go to operation on A. So it goes to A dot B. Then dot followed by B. So on B there will be a go to operation. So it goes to here. Dot at the end. So it completed. Then what is I5? Dot B. Dot B here. That will becoming as B dot. Right? Then once again here dot followed by B, we are adding the B production. Then what is this information? How we get this information? First of beta A. So first of beta A means, what is a beta here? A. What is A? It is a dollar. So first of A dollar, simply A. So we are including A. So here dot followed by B, capital B. So there is a go to operation B. So then simply it's going to B dot A, dot followed by terminal A. So on A, it going to here. Dot at the end. So there are no more go to operations. If you observe, all the productions in the grammar reached dot at the end. So it is a completion of the construction of the DFA groups or closure groups on this grammar. We'll see one more example. Right? Here, S dash gives, this is a grammar that is given. For this given grammar, we are included S dash gives as here. The first one is dollar. Right? I not group S dash gives dot S followed by dollar. Right? It is a dollar. Dot S add S production. Then what is the first of beta A? Always remember first of beta A. First of beta A. So here beta is epsilon, A is a dollar sign, simply dollar is included. Then dot L, this results to these L productions. Then what is the first of? What is the first of beta A? So it is a dollar sign. It is a dollar sign. Wait, it is not completed till now. At present, it is only the dollar sign. Dot multiplication R comma dollar sign only has to consider. Right? For this L. Next, here dot R. Dot R. So add R production. Right? Add R production. What is the first of beta A? Simply dollar sign. So we are including here, it is a dollar sign. The story starts here. Now, once again, dot L. Right? Once again, dot L. Right? Then dot ID. Here, listen. Here, what is the first of beta A for this one? For this one, what is the first of beta A? The first of beta A is assignment or dollar. So this is the result. So for this expansion, this is the assignment operator. This is the assignment operator. But for this dot L, they will be dollar sign. So we are writing once again these L productions. We are writing once again these L productions, right? With dollar sign. With this dollar sign. So is it clear? Here, for this dot L expansion, assignment is added as a terminal symbols. There are two groups. L gives dot multiplication or assignment. L gives dot ID assignment. These two are obtained from here. There is one more. L gives dot multiplication or dollar. L gives dot ID dollar sign. For this, obtained from this one. Since R gives dot L, we have to write L productions. For this one, the additional information is dollar sign. So, combining this both will result this one. Right? We are combining the both. That is the reason it is a dollar sign slash assignment operator. Dollar sign slash assignment operator. So there are no more new productions to be added. So the closure group is completed. Then it will have the go to operations. Then what are the go to operations? On S, on multiplication, on L, then on ID, then on capital R. So they will be a 5 go-to operations from the I naught group, right? They will be 5 go-to operations on the here I naught group. So what are that 5 transit go-to operations? One is on S, dot S becoming S dot dollar, right? That I1 group is completed. Then next, on multiplication, it is dot multiplication R becoming as multiplication dot R. Then R followed by dot followed by R, so we are adding R production. Then dot followed by L, so we are adding L productions, right? So here dot followed by terminal symbols, so the group is completed. That I4 group is completed. Then on L, there are 2 productions, so consider the 2 here. On L, dot L will become L dot. Argues dot L, once again argues L dot, right? Is it clear? Then on R, R dot, dot R become R dot. ID, dot ID will become ID dot. So I naught has 5 go to operations on S, on L, on R, on multiplication, on ID. So these are the 5 resultant closure operations: I1, I2, I3, I4, I5. Now I1 dot end, so no need. Then here I2 group dot followed by assignment. So there is a go to operation on assignment. So on assignment it going to I6. So dot assignment followed by dot. Assignment followed by dot. Excuse L assignment followed by dot R. R dot R, add R production. Dot L, so add L production, right? Add L productions. Then here, what is the first of beta A? First of beta A, simply dollar, first of dollar. So we included only dollar. So we included only dollar. Then I3 dot n is over. Then I4. I4 dot followed by R. So they will be on R, go to I7. Dot followed by L. So on L will go to I8. Dot multiplication, it go to I4, means it is recursive. It means it is recursive I4. Then dot followed by ID going I5 means nothing but this one. This is I5. So I4 here, this I4 on ID will go into I5. Right. Now dot R. So R dot. Then dot L dot. So here I7, I8 is over. Then we comes to I6. Dot followed by R, dot followed by L, dot followed by multiplication, dot followed by ID. So on R going to I9 means this is the I9. X gives L gives R dot. I10. This is the I10. R gives L dot comma dollar. Right? R gives L dot comma dollar. Right? L dot comma dollar. Then I11 on multiplication going I11. So dot multiplication changes as multiplication dot. R dot R. So add R production. Dot L add L production. Whenever you are doing this one, what is first of beta A? For this one, simply dollar. First of dollar. So simply dollar. So for the dot L followed by, for this also same. First of dollar. Simply dollar. Next, dot followed by R L multiplication ID. I13, I10, I11, I12. I11 means it is recursive step on multiplication. On ID, it goes to I12. On ID. On R, it going to I30. On L, it going to I10. Right? So finally, all the productions are end with a dot. So that is completion of the construction of the groups in this DFA of the grammar. Right? That canonical L11 collection is completed. When you observe I4 and I11, I5 and I12, I7 and I13, I8 and I10, these are productions are the symbol, but addition information is different. Here, these groups I4 and I11, if you check I4 and I11, the productions are the same, but the additional information is different. Here, it is a dollar end assignment. Here, it is a dollar. I5 and I12 also. I5 and I12 also. I5 and I12. Production is the same. But here, the symbols are the additional information is the different. So, this is the construction of the canonical LR1. Right? It is the construction of the canonical LR1. Right? So, now we will close this section. The construction of the canonical LR problems. Right? In the next class, we discuss the construction of the canonical LR table. Construction of the canonical LR table. Okay. Now I am closing.
Like, share and subscribe. Hit the bell icon for more updates.